Okay, we know how to add and subtract these guys. You know the rules. When it's subtraction, our signs change. When it's addition, they stay the same. Combine like terms, yada, yada, yada. Okay, so on numbers 1 through 4, what do our directions say? What do our directions say on numbers 1 through 4?
You use Pascal's triangle to expand the following expressions.
Thanks, Donovan. Beautiful. Okay, so we're going to ignore Pascal's triangle for now on number 1. Number 1, we see a binomial, x plus 5, and it's being taken to the power of 2, x plus 5 squared. Okay? So what we're going to do, x plus 5 squared, or anything squared, just means that you are multiplying by itself twice. X plus 5 times x plus 5. Okay? That's not too bad. You guys did this last year in math. We can multiply this out by using FOIL or the box method. I kind of like FOIL, the swooshies, so let's go ahead and do it. The F in FOIL stands for first. Where are my first terms? What do I need to multiply if I'm multiplying my first terms together?
X.
And x. Beautiful. My first terms. X times x. What is x times x going to give me?
X squared.
X squared. Next in FOIL comes the O, which stands for outside. Where are my outside terms?
5 and 5.
Ooh, one of the 5s is, Lily?
X and 5.
X and 5. Beautiful. This x and that 5, those are closest to my outside. What is x times 5?
5x.
5x. Positive 5x. What about my inside terms? If those guys were the outside, where are my insides? 5 and x. Beautiful. Again, what's 5 times x?
5x.
5x. Plus another 5x. And where are my last terms? Which two terms are my last terms that I need to multiply together? Lily?
5 and 5.
5 and 5. Beautiful. What is 5 times 5?
25.
25. Okay, so we multiplied that guy out. We expanded him. Okay? Last thing, always, are we simplified or do we have like terms that we can combine? Lily?
You can combine the 5x's.
Love it. 5x plus 5x. How many x's is that going to turn into? 5 plus 5 is 10. Beautiful. So in the middle.
10x? Oh, no, you're right.
Ooh, great question. I'm going to actually finish that question out. Okay, would we do 10x squared when we're adding them? No, it only turns into an x squared if they were being multiplied. Great question. So those guys turn into 10x's in the middle. X squared in front. Plus 25 on the end. And there's our final answer. Nice. Okay, so that one was pretty simple, right? To write it twice and then multiply. Do you guys want to write this thing out 3 times and multiply?
Not really.
Not really. Could you? Yeah, you totally could. But I agree with Gabe. There's a faster way to do a cubed power. Okay, and that is, if we remember, Pascal's triangle. Okay, so let's go ahead, turn your paper over to some blank space, because you're going to want to write down this triangle, this little pattern. Okay, so first we have, let's give yourself a 1 and a 1. 1, 1. Then give yourself a 1, 2, 1. We got that 2 by adding those 1's together. 1 plus 1 gave us 2. Start with a 1. Add those 2 numbers. What's going to come next? What's 1 plus 2? Beautiful. Add those 2 numbers. Again, what's 2 plus 1? And finish off with another 1. Okay, let's keep following this pattern. Start with a 1 again. Add those two numbers. 1 plus 3? 4. 3 plus 3? 6. 3 plus 1? 4. And finish out with a 1. Okay, let's do one more. One more row. Start off with a 1 again. 1 plus 4? 5. 4 plus 6? 10. 6 plus 4? 10. 4 plus 1? And finish off with another 1. Okay, you could keep following this pattern forever and ever and ever and ever and ever and ever and ever, but we're only going to do it to the 5th power. Okay, so our first row, if you notice the power, this would be if it's just to the 1st power. We don't really deal with them because anything to the 1st power is just itself. This guy is if it's to the 2nd power. And so on and so forth. 3rd, 4th, and 5th. Good little indicator. 2nd power, you see a 2. 3rd power, you see the 3s. 4th, the 4s. 5th, 5s. Okay, so keep that triangle on the back of your paper. You're going to need it. Turn your paper back over. Looking at number 2. What power are we working with? Cubed. Okay, so let's go back to our cubed row. For my cubed row, I need a 1, a 3, a 3, and a 1. Okay. Write those down. 1, 3, 3, and 1. Okay, that's our little pattern guy. Now what we need to add on to him are the terms in our binomial. My first term is what? X. Okay, so each one gets an X, X, and X. Okay, remember our first term starts high and goes low. So it starts with our highest, 3, 2, 1, 0. Okay, then we need to add our second term onto these guys. What is my second term in my binomial? Negative 3, negative 3, negative 3, negative 3, negative 3. Second term starts low and goes high. So start 0, 1, 2, 3. Okay. Now we have a whole bunch of mumbo jumbo here. All we got to do is multiply these terms out, figure out what is going to be our final terms in our polynomial. Okay, so let's look at our first guy. Just this guy right here. We don't care about a 1. That doesn't change anything. And what's anything to the 0 power?
1.
Another 1. We don't care about another 1. So our first term is just x cubed. What we're left with. Okay. Again, we're multiplying these pieces together to get the final term. What is negative 3 to the 1st power?
Negative 3.
Just negative 3. What's negative 3 times 3?
Negative 9.
Negative 9. So our next term is negative 9 x squared. Sweet, got our second term. Let's go to our next guy. What is negative 3 squared? What's negative 3 times negative 3?
Negative 9.
Is it negative?
Oh, wait.
Negative times a negative?
Positive.
Positive, so we get positive 9. Then what's positive 9 times 3? That 3 in front. 27. So my next term, positive 27 with 1x, or x to the 1st power. Okay, well then my last term, again, we don't care about a 1 and we don't care about anything to the 0 because that's just 1. So now we just got to figure out what is negative 3 cubed. What is it, Eli?
Negative 27.
Yes, sir. Why is it negative though?
Because you're squaring a negative.
Ooh, very close. We're cubing a negative. So it's an odd power
Right.
with a negative. Absolutely right.
Wrong name.
Negative 27 for that final term. And guess what? There's our final answer. Okay? Let's do that one again. We're going to skip number 3. Let's just look at number 4. Ooh. What power are we taking this to? What line do we need? Ooh, the 5th power. Okay, let's see what coefficients we need on our back for 5th row. These guys right here. Give yourself some room. Go into number 3's room if you need it. Let's do, what was it? 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1.
Skipping 3.
Yep, skipping 3. Okay, so it's being taken to the 5th power, so we needed that 5th row, right? Okay, well, first things first, they each need the first term. What's my first term?
X.
X, so give them all an X. X, 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 X. Okay, first term starts high, goes low, so starts with our highest 5. 4, 3, 2, 1, 0. What's my second term? Each one needs a second term.
4.
4, so give them all a 4. 4. 4. 4. 4. 4. And 4. You don't have to put the parentheses. I like putting the parentheses that says we're multiplying everything, right? Okay, then our second term starts with the lowest and goes high. So 0, 1, 2, 3, 4, 5. Whew. It's a lot of mumbo jumbo. Okay, let's figure out what each term is, right? Just multiply all those little pieces to get your terms. So my first guy right here. We don't care about 1 and we don't care about 4 to the 0 because that's just 1 as well. So we're just left with x to the 5th. Okay, next term, let's figure out what this guy's going to be. 4 to the 1 is just 4. What's 4 times 5? 20. So my next term, positive 20, x to the 4th. Okay, my next term, what is 4 squared? 4 times 4?
16.
Okay, what's 16 times 10? Just added,
60.
thank you. 1 plus 160x cubed is my next term. Okay, next guy. Ooh, 4 cubed. Anybody know what that is? 4 times 4 times 4? Or think 16 times 4?
64.
Nice. Okay, it's going to be an even bigger number. What's 64 times that 10?
640.
Good job. Plus 640 with the x squareds attached.
My goodness.
That's a lot.
I just hope I never stumble against this problem.
Okay, only 2 more terms. 2 more terms. What is 4 to the 4th? Okay, what's 64 times 4? Put in your calculator.
256.
256?
Yep.
Now you're really going to need a calculator here. What's 256 times 5?
Oh my goodness.
65,536. Oh, that's a lot.
Wait. I got something different.
1,530.
Never mind, yeah.
1280 or 1,280. Okay, plus 1,280 with just 1x. We're almost done. We don't care about 1, and we don't care about x to the 0 because that's also 1. So now lastly, what's 4 to the 5th? What's 256 plus another 4?
That's enough.
256 times,
1,000 and 1,024.
love it. And no x is attached to that guy, so 1,024. Oh my gosh, look at that polynomial. You're so glad you didn't have to use all the swooshies to multiply that out. It's a big guy.
Years.
It'll take years.
I
I don't know about years, but probably
Just a long time.
long time.
You know what would be worse?
Pascal's triangle.
That's how he shortened it?
Mm-hmm. Yep, so that French
You know
dude,
what?
Pascal, he's like, that's annoying. This is him shortening it.
You know it would take years
Not very
to solve.
shortening, but okay.
Take that, take the 5 out of this problem
Uh-huh.
and turn it to 1,000,000.
Oh yes, that would take years. Yes, yes, yes. Okay, that was multiplying. Okay, when we get into big powers, you don't want to multiply it out 5 times, right? So we use a little trick. Give me a fist of 5 on Pascal's triangle. Finding the little pattern, identifying what the terms are by multiplying them. I'll be impressed. Show me fist of 5. Even you guys over there who aren't listening. Show me fist of 5. Okay, cool. Actually, that's better than I thought. Okay, so just like with multiplication, how there's a faster kind of a little cheat way, with division, there's a cheat way as well. And we call it synthetic division. Okay, we don't want to long divide these guys. We want to use the cheat way. Okay, so first step, remember, change the sign on what we call our divisor. Our divisor is this guy right here. Okay, so we need that guy, but we need to change the sign on him. So instead of a positive 10, it's going to be a nice. Okay, so we have negative 10 on the outside. Draw your little division symbol. Okay, just like on our starter, we only care about the coefficients, the numbers at this point. So grab your coefficients. Whoops. 9, 96, 66, and 58. We'll put the variables back on at the end, but right now we don't care about them. Draw your line. Okay, now we just follow the pattern. First things first, drop your first guy. Okay, now remember our pattern. What do we do with these two numbers, negative 10 and 9? Multiply. What is negative 10 times 9 going to give me? What's going to go in this spot right here?
Negative 90.
Negative 90 when I multiply. Okay, now you just combine straight down. What is 96 minus 90?
6.
Positive 6. Same step. What's negative 10 times 6 this time?
Negative 60.
Negative 60. 66 minus 60.
6.
Positive 6 again. Again, 6 times negative 10.
60.
Negative 60 again. What's 58 minus 60? Gonna be in the
Negative
negatives. Nice. All right. That last number right here, that is our remainder. We're just gonna label him with an R. Okay, last thing we gotta do is put those variables back onto our answer. So we started with v cubed, which means we're gonna start with v squared down here. V squared, positive 6v, positive 6. We're just taking away a v each time. And there's what we call our quotient. Okay, way faster than doing that long division stuff that we all hate. Okay, so let's go ahead and try that again, you guys. Practice makes perfect. I need to grab this positive 2, but what do I need to turn it into?
-2.
Negative 2. Negative 2 on the outside. Draw your little division symbol. We just care about the numbers, the coefficients. What's my coefficient on that guy?
1.
You guys are good. 1, -8, -10, 16. Taking our x's off, we'll put them back on at the end, but right now we don't care about them. Draw your line. Drop your first guy. And follow our pattern. Okay, multiply. -2 times 1 is going to give me what? What's going to go in my next little space?
2.
-2. Then combine. -8 minus 2 is going to give me what down here?
-10.
-10. -10 times -2.
+20.
Nice. My next spot, we get a +20. -10 plus 20, since it's positive. -10 plus 20.
So, -3.
Ooh, not quite. I'm in the negatives. I add 20, Gabe. +10. Last step, -2 times +10.
-20.
-20. 16 minus 20.
-4.
So what's my remainder?
4.
Nice. Whatever that last number is, that is your remainder. What's my last step? We took my x's off, so what do I have to do?
Put it back on.
Put them back on. We started with x cubed, so just drop a power. X squared. Next guy gets 1x. +10, no x's. And there's our quotient. Quotient and remainder. All right, you guys are getting it. You guys are getting it. More practice. Here we go. Number 7. I need to grab that little divisor, but instead of -2, I change it to a
Positive.
+2. +2 on the outside. Division symbol. We only care about the coefficients here. We have a 1, a 7, -19, and 1. Alrighty. Draw your line, drop your first guy. 2 times 1, what's going to go in my next little space?
2.
+2. Then combine, right? When you're going down, you're adding or subtracting. When you're going this way, you're multiplying. So what's 7 plus 2?
9.
9. Okay, now we're back to multiplying. What's 2 times 9?
18.
18. -19 plus 18, since it's positive.
-1.
Mm-hmm. Love it. Back to multiplying. 2 times -1.
-2.
-2. 1 minus 2.
-1.
-1. So what's our remainder?
-1.
-1 is our remainder. What's my last step? I took those v's off. What do I have to do?
Put it back on.
Put them back on. Okay, we started with v cubed, which means this guy is going to be v squared. +9v minus 1. He doesn't get a v. And that is our quotient. So we just drop a power and then count down, right? 2, 1, 0. Bless you. Do it one more time. And then this is all your assignment is on, is multiplying, okay, using that Pascal's triangle. There are easy ones. And then dividing, synthetic division. Okay, last example. I need to grab this -7, but I need to change it to what? Positive 7. Positive 7 on the outside. Draw your little division sign. Grab your coefficients. I have 4, negative 23, negative 25, negative 71. Big numbers, don't worry, they have to follow the same rules. Draw your line and drop your first guy. Okay, first thing, we're dividing when it's on the outside. What is 7 times 4? What's going to go in my next little spot?
28.
Mm-hmm. Okay, on the inside, we add or subtract, meaning what's negative 23 plus 28, because it's positive.
5.
Positive 5. Back to the outside, which means we're multiplying 7 times 5.
35.
Booyah. Inside, adding and subtracting, negative 25 plus 35.
10.
Kaylee's on top of this, you guys. Back to the outside, so we're multiplying 7 times 10.
70.
Oh, so close to no remainders. Negative 71 plus 70.
Negative 1.
Negative 1. What's my remainder?
21.
Negative 1. Whatever you get right here is your remainder. Okay, we took our x's off. What do we have to do with them?
Put it back on.
Put it back on. We started with x cubed, which means this guy is x squared. Positive 5 gets 1x. Positive 10 doesn't get any x's. So there's our quotient.